Okay. Yeah. So this is week 2 of the problem solving session for NPTEL course Getting Started with Competitive Programming, and today we are going to solve some problems from the paradigm searching and sorting. So today's agenda, I hope I've started the recording. Yeah. So we are going to solve two problems, and so I will share the problem statement with you and I will read it out to you. So I will give you some time to understand the problem, then we will look at the examples and try to solve them, and after that once all of you are clear with the problem statement, I will ask you to think about approaches and then we will discuss the approaches. And okay, so yeah, let's so this is a TA session which happens every Friday 6 p.m. to 7 p.m. and the course instructor is Professor Nildhara Mishra, and she does not join this session. So this session is taken by me. I am Nikita Yadav. I'm a PhD student in CSA department and I'm one of the TAs for this course. And the problem solving session is in this session we just discuss some problem related to every week's content, just as practice problems. Yes, you will have a live sessions with her also, and you will receive announcement for those. Yeah. Let's look at it. Okay. So the problem statement, problem 1, let us look at it. So you have a set of n slips of different colors. The ith slip has a number Li written on it. And suppose we have a set S of 3 slips with numbers A, B, C written on it. This collection of slips S is called a nice triplet if the numbers satisfy all the following conditions. A is less than B plus C, B less than C plus A, C less than A plus B. Now the question is, how many different nice triplets can be formed? And the condition is 2 collections of slips are considered different when there is a color that occurs in only one of them. So I will also copy paste this on the chat box. I'm giving you a few minutes to read the problem again. Is the problem statement clear? I'll just try to open my whiteboard so that I can explain. Yeah, I'll explain. Just give me a minute. Sorry, I've been facing some issue with whiteboard. Let me resolve this. I'll just unshare my screen for one. Okay, it doesn't seem to be working, so let's use the slides only. Okay, so the first question is that we are given so let me just go back here again. So we are given n slips of different colors, and each slip has a number written on it, okay, which they're calling li, and so that's the input. And then you need to tell that how many triplets are there in this collection of n numbers which satisfy this property, which is the triangle property, that the sum of any two edges is greater than the third edge, right? So then here we are given some extra information, like two collections of slips are considered different when there is a color that occurs in only one of them. So what does this mean? So this means that since all the slips are of different colors, okay, so that means we can only pick slip. Whenever we are picking slips, we cannot repeat them. We have to always pick 3 different slips, and so that will be, that is if you're so now coming back here, so simply we can say that we are given n numbers, and we can pick any 3 numbers, and then we will check the property, and we cannot pick any number again, okay. So example here would be, let's say n is equal to 3, and the values that we have is 1, 2 and 3. So now so now you tell me that how many triplets are here which satisfy the triangle property. First of all, tell me how many triplets are there. You can write on the chat box. Right. Others? Okay, great. Okay, now tell me, if your input is 1, 2, 3, then how many nice triplets are possible which satisfy the triangle property? Okay, most of you got it right, so let me explain it. Yeah, so the triangle property, which is let me not confuse you by saying the triangle property, but let us just say that there is a property of that these 3 numbers should satisfy. That is the number should be greater than the sum of the other two numbers. So the property is, if we have these three numbers A, B and C, then the property is that A must be greater than B, A must be less than B plus C, B must be less than C plus A, and C must be less than A plus B, right? So this is the property that we want the triplet to satisfy. Now in this example we have only one triplet, which is 1 2 3, because there is only one possibility of triplet here. There are only three numbers, and 1 is less than 2 plus 3, fine. 2 is less than 1 plus 3, fine. 3 is not less than 1 plus 2. I'm using exclamation mark to say that it is not. Okay, because 1 plus 2 is also 3. So then, now the question is that given an array of n numbers, you have to tell how many such triplets are possible. So let's take another example, which is, let's say n is equal to 4 and the numbers are 1 2 3 4. Now take your pen and papers and tell me that how many nice triplets are possible for this example. The numbers are 1 2 3 4. Once so Nitish said 4, 1 1. Okay, Nitish, can you check again, or could you explain to me how you got 4? One is that can be formed as 4. Okay. Nice. I mean, it's good that you're trying. Okay, let's solve this example. Okay, so how many, okay, just quickly answer me, how many triplets are possible? So give yeah, so since there are so we have to choose 3 elements and total are n elements, so there are nc3 triplets which are possible. Okay, which is okay. So so NC3 triplets are possible, which is n where n is 4, 4C3, which is 4 factorial into 4 minus 3 factorial, which is 1 factorial, divided by 3 factorial, which is 4, right? So only 4 triplets are possible. Great. So now let's look at these. What are these 4 triplets? So one is 1, 2, 3, other one is 1, 2, 4, and what is the next one? 2, 3, 4. 1, 2, 3, 1, 2, 4, and sorry, I missed one. 1, 3, 4. And should sufficiently space them. Okay. Now for the triplet 1, it is the same as first example, does not satisfy the property. For the triplet 2, 1 is of course less than 2 plus. Now we should check for the last one only. 4 is not great. 4 is actually greater than 1 plus 2. It should be less. So it does not satisfy. So second one does not satisfy the property. Then the third one, 4 is less than 2 plus 3. 3 is less than 4 plus 2. 2 is less than 3 plus 4. So this satisfies the property. So this is one of the answers, which is in bold. And for this one, 4 is actually equal to 1 plus 3. So it also does not satisfy the property. So there is only one triplet which satisfies the property, and which is 2, 3, 4. So I hope this is clear to everybody. If not, then please ask me. Animesh, is it clear? Okay, let me repeat. So the question so we are given n numbers. This is your example. Okay, this is the example I'm talking about in bold. N is equal to 4. 4 numbers are given, 1, 2, 3, 4, and you have to check every triplet, which is every set of 3 numbers. And how many 3 numbers can we choose from 4? That is NC3, that is 4C3, 4. Okay, now I have listed those triplets whichever are possible, and those are these 4 possibilities. Now we have to check every triplet, that whether the triplet satisfy this given property or not, which is this. Let us call the 3 numbers as A, B, C, and they should satisfy this property. If they satisfy this property, then that is a nice triplet, and that is our so then we will increment our answer. We have to find the number of nice triplets. So in these 4, only one of the triplet, which is 2, 3, 4, satisfy this property, and therefore our answer is only 1, which is it clear now? Okay, good. So now the problem statement is clear to all of us. So now let us first tell me how you can solve this problem in the most naive way, like brute force way. You can post your approach, your ideas on the chat, or you can also unmute yourself and speak.
May I begin?
Yes.
So what I think is we can just run 3 loops, and that, let's say the first one starting from index I, the second index, that will be j, will be greater than I, and the third index k will be greater than j as well. So we can run these three loops to find all the triplets, and then we can check for every triplet if it is a nice one or not. That will be the brute force, I suppose.
Right. Yeah, that is great. Yeah. So I hope everybody understood what Kushak just explained, and if you did not, then please let me know. Yeah. Okay. So I am assuming that everybody understood the brute force method. So what is the time complexity of this brute force method?
It will be n cubed.
Right, right. Great. Nice. So now can we do better? Can we think of something better?
Well, I just thought about an n square log n approach as well.
Great. But okay, that is great. Let us wait for others to just think and
Sure, ma'am.
yeah. Let's just wait 2 minutes and then we can discuss. Okay. If we order the numbers, we can retrieve the yeah. So numbers can be repeated. Mm. And that is right. If we have 2 3 4 4, then two there are two triplets of same I mean same numbers 2 3 4 repeated. I just wish this was working. Don't know why. Okay, let us discuss the solution. Okay, first okay, so some of you pointed out that we can sort the array. Good, but what do we do after sorting the array? Why is it helpful? Okay. So I would like to invite any one of you who wants to, who wants to discuss the approach. Like one by one you can go. Right. Yes, go ahead.
All right, ma'am. So my approach was like first we sort the array,
Yeah.
then we start two loops, right? So first we will have the ith pointer that will go from 0 to n minus 3, I think, yeah, n minus 3, and then we'll have the jth pointer that will go from I plus 1 to n minus 2, and then on the remaining part we can run just a binary search because we know the array in front is sorted, right? So we can just run a binary search and check how many elements in front we have that have a value less than the sum of the values at previous two pointers, right? The value at ith index and the value at jth index. So those elements that have a value less than that will be considered to be eligible for a nice triplet, and therefore it will be an n square log n solution.
Right.
So it's just
Okay. Yeah. That is right. That is right. Okay. Um, so let me go. Let me explain that again with an example, and so that my screen is not. I've not shared my screen. Is my screen visible?
yes, ma'am.
Okay. Okay. So let us take this example to just walk through the approach that was just suggested by Kushag. So he suggested that we can take two, so we can choose two numbers, and then we can find all those numbers which will satisfy the property. I mean, once we have two numbers, then we need to the third number we can choose in such a way that the number is always less than the sum of these two numbers, and that is possible once we have sorted the array. That is, let me just just go over this here. So let us so I will just he explained it from the front, but let me just say it like this, that let's say that I choose number 7 and I choose number 5. So these are the numbers that I've chosen. So here let me say that there is one pointer at 7. I'm not able to, I'll color them. There is one pointer at 7, another pointer at 5. Okay, and so already we have these two numbers. So now so any number which we, so the difference between these two numbers is 7 and 5 is 2. So if I choose any number which is smaller or equal to 2, then then 7 will always be greater than the sum of this 5 and the new number, because if I choose any number x which is less than equal to 2, then x plus 5 will always be less than 7, right? So I need to choose only those numbers which are greater than 2, which is the difference between 5 and 7. I mean 7 minus 5, which is 2. So then we can search for these numbers because this side of the array is sorted. So then I can do a binary search here and find the first number, index of first number which satisfy this, which is actually greater than the difference of these numbers. So which is 3 here. Okay. So now we don't need now 3, 5, 7 will be a nice triplet. Why? Because 3 comes before 5 and 7. So it will always be less than the sum of 5 and 7. Now 5 is anyway less than 7. So 5 will still be less than the sum of 7 and 3. And 7 now is less than 3 plus 5 because we have chosen 3 in such a manner that it is always less. I hope this is clear. Okay?
Yes, ma'am.
Okay. So then after that, now tell me, do I need to check for 4? That is the trick here. Like, I'm claiming that we do not need to check for 4. Because 4, again, 4 argument is 4 is less than 5. So 4 will be less than the sum of 5, any number, any two numbers which are coming after 4, right? 5 will be less than the sum of, because 4 and 7, because one number we know is definitely greater than or equal to. Even when it is equal to, then we are adding a positive number into it, right? So it will always be. And 7 is less than 4 plus 5, that we already the same argument, because we have chosen this x number greater than the difference between 7 and 5. So once we find the first number here which is going to satisfy the property, then so for this pair 5 and 7, we can say that both 3 and 4 can be chosen as the third number. So we can add 2 to our answer here. Answer plus equal to 2. Or I will just say answer is equal to 2 right now. Okay. Is this so this is our first iteration that I have done. Is this clear? I'm seeing some yes and no's. Okay, great. So now so there I am just going to, so here the 7, so I have here 2 pointers, right? One is at 7, one is at 5, and we were trying to find x in the left side of the array, right? Now we will move. Now let us change the color back to what it was before. I think it is one. So then after that we move the pointer here. Now this is 4. Now we have moved the pointer to the left side, 4. Now our pair is 4 and 7. Now we need to find for 4 and 7 the third number, the numbers which can be placed in the third place, basically. So now again the same trick. So the difference between them is 3. So we need to find numbers which are greater than 3. Right? So here, as we can see, there is no number greater than 3 in the left hand side array which is left. So therefore our answer does not get incremented. Now let us again move the pointer to here. Now another trick is like here we did not find any numbers, right? Now will we find like for the pair 4 and 7, we were not able to find any triplets, like any number which can be placed at C. So will we be finding any numbers if we if we keep going like in the array, if we keep traversing this green pointer in the array like this? So my argument is that we will not, and the reason is that because if we keep moving left in the array, the difference between the red number and the green number will keep increasing, and already we have seen that there are no numbers which are greater than the difference. So we can now break from here, we can break the loop here, and now we can move the red pointer. Is this also clear? No. Okay, we will go in the next iteration, and let's see now. So answer is currently 2, and now let's do the next iteration. So in the next iteration we are on 5, and 4 is our green, the green pointer is at 4, red pointer is at 5. So A is 5, B is 4, and we are looking for all those numbers which can be placed at C. Okay, so again the difference between them is 1. 5 minus 4 is 1, right? So all those numbers which are greater than 1 will satisfy, which is 2 and 3. So then we will add 2 here. That's the I hope, Sunil, that is clear now, and if not, then let me know. Now what will we do? We will move the green pointer. So we move the green pointer here. Okay, now the difference between 3 and 5 is 2. Now 2 and all the numbers which are greater than 2 in this part of the array, there is none. So then this loop will break here. Okay, so that means we are going to move the red pointer at 4, and green pointer will again start from 3. Now the difference is 1 here, right? So any numbers greater than 1, 2 is there, so 1 triplet is possible, which is 2, 3, 4. Now after that, if we move it to 2, so now green pointer will move here to 2. So when it moves here, then the difference is 2, and the left array has only one element, which is 1, which is less than 2, so not possible. So then this loop also breaks, and then we will move the red pointer here, green here, and difference is 1. Numbers only greater than the difference will satisfy, and we do not have any number greater than difference, which is 1. So therefore this does not satisfy, and after that there are no more possible triplets here. So the answer is 5. Is this clear? Sunil, can you ask what part specifically is not clear to you? And others, could you tell me if it is clear? Okay. I just wish my whiteboard was working, but not. Okay, anybody who is not clear, please write again on the chat box so that I know and I can go over again. I'm assuming that when you wrote it earlier, that time it was not clear, but probably not. Okay, let me go over it once more. Let us choose this subarray, okay, as our example 4. We have only these 4 numbers right now. One, two, three, four. Okay, so we will start. I am saying that whenever you are given an array, first you sort it. Okay, so this is a sorted, that I am already assuming that it is sorted. So then you are going to have 2 pointers. Let us call them red pointer and green pointer here, and then your red pointer is they will start from the last element and the last second element. Okay, and you are going to keep moving them, and you are going to find the third number which satisfies the property. When you already have 2 numbers at green pointer and red pointer, you need to find the numbers which satisfy the property if you already have these 2 numbers. So 4 is so the red pointer is at 4, your green pointer is at 3. Okay, then I am saying is that if you have 2 numbers, any 2 numbers, here we have 4 and 3. So I am saying if you so since 3 is less than 4, if you will choose any number, this will always satisfy the property that 3 is less than 4 plus x. So x can be anything for this one. Okay, and if you choose any number from this array, which is the left side, then that number will always be less than the sum of 3 plus 4, because that number is anyway smaller than 3 and of course 4. So that is out of the picture. Now the only condition that is like we need to check is that that 4 is less than 3 plus x. So for this condition we have to choose x suitably. So 4, that is 4 is less than 3 plus x, which is saying that x is greater than 4 minus 3, right? That is the difference. So that means x greater than 1. So that is the idea. So you choose all, you find all those numbers which are greater than the difference. Okay, so all the numbers which are greater than 1, there is only 2 here. So there is only one triplet possible in this, that is 2, 3, 4. Right, after that, once you have found this, you will move the pointer. So the pointer will be moved here, green pointer. So now these 2 numbers are 2 and 4. Difference is 2. Now in the left subarray, do you have any number greater than the difference? No, we do not have. So the answer will not change. Right? After this, the red pointer will actually move. Now since we have exhausted, now we have reached a point where we are not finding any more triplets, nice triplets, then we move the red pointer. So the red pointer will then move to 3. And so does the tutorialpoints.com output. Okay, is it clear now? Let me try. Okay, great. So now can we do better before looking at the implementation? Okay, so just one second. So here when we are searching for the third number in the subarray, remember we will be using the if we do not use binary search, if we just search for it like by going at every index from left, then the complexity will not change, it will still be order n square. If you use binary search to search this number, and why can we use binary search? Because all the numbers which are greater than the difference will satisfy, right? So you just need to find the first number which is greater than the difference, right? And all the other numbers will satisfy. So binary search you can use, and after that the time complexity will be order n square log n. If you're not clear about the complexity, then also let me know. Move to 3. Okay, so the red pointer now moves to 3, the green pointer is at 2. Now the difference between these two is 1. So in the left subarray we will look for the numbers which are greater than 1, but we do not find any, so therefore there is no nice triplet. Now after this, since we cannot move the red pointer further, right, we will not be able to form any triplets, so therefore our algorithm will terminate here. Okay, great. Okay, just let me quickly share the code then. Okay, so first we read inputs from here to here, right, n and then n numbers, and we are creating a vector of integer here, and after that we sort these numbers, right? And here if we do not use binary search, so this is how it will look. So first we are starting from say I equal to 1, and we'll go to n minus 1, then j is equal to I plus 1, and j is less than n here, and difference is this. Okay, I explained to you like that, but I have written it like this, so that's the problem. I mean, it's not much of a problem, just that here so it will be like this in the code. Okay, so that I'm just quickly going to explain. I just hope you don't get confused. So just assume that this is one pointer and this is the second pointer. Everything remains the same. Okay, you will find the difference between the two, and you will look for the numbers in this. Then you will move this pointer. Okay, then you will move this pointer here. So that's how the algorithm will run. And then once you finish, when you're done with one iteration, then you will move the red pointer on the right side. Okay, so like the first loop is for, let's say, red pointer, second is for the green pointer, and they are going to move like this. Is anyone okay? Okay, so then I am here finding the difference between these numbers, and then I am going to search for the number which is going to find the first number which is greater than the difference that we have used here, this for loop, which starts from 0 index, goes till I mean I minus 1, and we are going to find if the number is greater than the difference, we break out of the loop. We have found our k, and then we'll add on to the answer I minus k. And if we do not find any number, I mean if we do not find any number which is greater than the difference, then we are going to break from this j loop and going to start again by incrementing I. So the first loop can run n times, second loop n times, and this also, like asymptotically, like if we are speaking roughly, then it is also n times. So there are 3 loops. So that is why the complexity is order n square. You can also work it out like mathematically. It will be like summation from I equal to 1 to n. It will be I roughly, I mean times n minus I. And if you will solve this, you will get that it is order n cube. Summation I, I'm going to write here I equal to 1 to I is less than n. Okay. Now, so this is, so the time complexity is order n cube here. Now, so we are, so we can clearly see that this loop is actually adding here order n times. So then since the array is sorted, why not do a binary search? So we can replace this with the binary search here, and we will search for the first element which is greater than the difference. And so let us call this binary function here, which is taking as input the vector of integers. Low is set to 0, high is set to I minus 1, and x is the difference here. And so whenever we find that the mid of the array is greater than x, then we are going to return the mid. This is the condition. So I'll be sharing the code and you can look at it. And whenever the mid is less than the difference, so at that time we are going to move to the right hand side. And whenever the difference is greater than whenever this mid value is greater than the difference, that means that this is not this, there are more possible numbers on the right, on the left hand side. So we are going to move the pointer to the left. We are going to jump to the left, I mean the binary search. So we will, this is that part. So this is the binary search function, and then we do the binary search, and binary search runs in order log n. So the time complexity, since there are 2 loops, n square times log n, so the time complexity is order n square log n. Now I hope this is clear. Now, yeah, so let us now think about if we can do better than this. Yeah, so I'm just giving you a hint that a order n square solution is possible. Yeah, you can use library functions. Yeah, definitely. So order n square solution is possible, and the approach is very similar. So please think about it for a few minutes. So I am actually, I'm not very like I don't write generally code in Python, so I'm not very much familiar with the syntax of Python. But maybe you can take this as an exercise. Yeah, thanks Kushagra. Yeah, Abir, you have suggested an approach. I'll also give others some time to think. If we first find out all the possible triplets and check for nice ones, that is order n's cube, because n order n cube triplets are possible. Subarrays which are nice triplets, I did not understand. I mean, you are saying that any triplet which is possible in that subarray is a nice triplet. Okay, since we are short of time, so I will discuss the approach that I have, but I'm sure other approaches are possible, and please think about it, and you can post your approaches on the Discord channel and discuss. Right? Okay. Again, the same example: 1, 2, 3, 4, 5, 7. Okay. So here we will have. So earlier we were having two fixed pointers. One was the red pointer, one was the green pointer, and they were actually like we had chosen those two elements, and then we were looking for the third element. Now we will have only one element here, which is, let's say, 7, and we are going to look for other two elements. Okay, so we are going to use two pointers here which will be moving. One is this green pointer and one is this blue pointer. And this green pointer will move towards the right, sorry, green pointer will move towards the left side, and the blue pointer will move towards the right. Okay. So now the idea is that if the sum of the green number and the blue number is less than 7, so that means we need to increase this sum, right? Because then only we will be able to satisfy the property. So here the sum is 1 plus 5, which is less than 7. Sorry, 1 plus 5 is 6, which is less than 7. So we will move the blue pointer here, and it will come at 2. Now even when I keep it at 2, it will again be less than, it will be again equal to 7, but we want the sum to be greater than 7, so we will again move it here. So now when this now one pointer is at 3 and one is at 5 and we have 7, so 3 5 7 will satisfy the property, right? And so now we are saying that so all these numbers between this, like 3 and 4, again I mean it's almost similar, so 3 4 and 7, sorry, 3 5 and 7 and 4 5 and 7, they will satisfy the property. Okay, so these are the numbers that we get. Is this clear? So whenever okay, not like that. So here 3 5 and 7 we are going to check, and this satisfy the property, right? So that is one, that will be one of our answers. Then after that we see that 3 plus 5 is greater than 7 8, so then we are going to move the green pointer. And it will come here. So now 3 4 and 7 will satisfy the property. Now sorry, it does not satisfy the property, so that will not be our answer. I'm sorry, I think I must have confused you. I'll just go over it once because I myself got confused here. So we have two pointers, one is the left pointer, one is the right pointer, and it is like two pointer sum. So whenever the sum of these two numbers pointed by these pointers is greater than this last number which we are comparing with 7 here, when it is greater than that, then we are going to move the right pointer. Whenever it is less than that number, we are going to move the left pointer. That is all we are going to do. And whenever we have these numbers, we are going to check whether it is a nice triplet or not. If it is nice, we are going to increment our answer. So let's just run it and see. So currently we have 1 5 and 7. 1 5 and 7 does not satisfy the property, so it is not nice. So and 1 plus 5 is less, which is 6. 6 is less than 7, so we are going to move the blue pointer. Blue pointer will come here on 2. Okay, now 2 5 7, is it a nice triplet? No, it is not nice triplet. And 2 plus 5 is equal to 7. Okay, we want more than 7, so we are going to move again the blue pointer. Now 3 5 7, is it a nice triplet? Yes, it is nice triplet, so answer will be incremented by 1. Now 3 plus 5 is 8. 8 is greater than 7. Okay, so we are going to move the right pointer here. Okay, now we have the triplet 3 4 and 7. Is it a nice triplet? It is not a nice triplet. So then we are, so answer is not incremented. So far we have only one answer, right? And after that we are not going to, because if we change any pointer, then they will cross, so we are not going to change it. So answer so far which we have is 1. Now next time we have 1 2 3 4 5 7. Now red pointer will be moved to 5. Now this will be our green pointer will be at, I mean the right pointer or green pointer will be at 4, left pointer at the first index, and then again we are going to do the same. So 1 4 and 5, not a nice one, and 1 plus 4 is 5, so we are going to move the blue one. It will come here. Now 2 4 and 5 satisfies the property, so this we are going to increment our answer plus 1. Then 2 plus 4 is 6, greater than 5, so we are going to decrement the right pointer. So we get 2, 3 and 5. Now 2, 3, 5 is not nice because 2 plus 3 is 5. So then we go to the next iteration. Now this is red pointer, this is green. If I make a mistake, then do let me know. Okay. Yeah, we break the loop when both converge. So I must have made some mistake. Was I must have said 3 plus 5 is not less. Yeah. Okay. So we are doing this run. So here we have, so right pointer is at 3, left at 1. 1 plus 3, 1, 3 and 4. Not a nice one. 1 plus 3 is equal to 4. Okay. So therefore we increment the left pointer. Now we get 2, 3 and 4. So whenever, so at a time we are only going to increment one of the pointer, either left or change one of the pointer, increment left or decrement right. Okay, and whenever we change one of the pointers, we will get a new triplet, and we are going to check whether this new triplet is a nice one or not. Okay, if it is a nice one, we are going to increment the answer. If it is not a nice one, then we will check again that whether to increment or decrement based on the sum of these two. Right? So here 2, 3, 4. 2, 3, 4 is nice. So, but they have converged here, so we don't change. Nice. So I will add here 1, and after that we have 1, 2, 3, 4, 5, 7. Sorry about this. So now we have reached here. This is 4, right pointer at 2, left pointer at 1, and this is not a nice one, which we know. So the answer is 3. So is this clear?
Ma'am, I think we got a confusion there. Can we get back to the page?
Yeah. 1 second. I'll just. Sorry, I just need to connect my laptop to the battery. Yeah.
Yes, ma'am. Sorry, am I audible clearly? Audio is echoing, ma'am.
Audio is echoing. It is not echoing for me.
Ma'am, my audio is coming from your side as well. It is clear now. It's clear.
Okay.
Yes, ma'am. So, ma'am, here, what I was thinking is, let's say in dual pointer, we got our 2 pointers at 2 and 5. We didn't got a valid uh, triple, so we'll move the 2 to 3, right? We'll
Come again.
will I'm suggesting that, let's say we had the pointers at 2 and 5, so the value is equal to 7, so we'll try to increase the left pointer, right?
Yeah.
Yes. So in the next iteration, when we are at 3 and 5 and we see that this is correct, then we'll increase this by 2, right? The answer will increase by 2 because we'll consider 3 and 4 both to be valid for this triple.
Yeah.
And then we'll decrease the 5, right?
So okay, I must have made a mistake there. Right.
No, I'm
You are
also
right.
getting confused there only.
Yeah,
Yes, ma'am.
you are right. You are right. So I have done a mistake in the calculation here. Right. Sorry about that. Yeah. So the answer will be, yeah, the difference,
Uh,
yeah, number.
that way there will be one more two, and we get the answer like five, like the last time. Yes. Yeah.
Okay, yeah.
Okay. Yes, ma'am.
Thank you for the correction. I got confused.
No problem. Thanks a lot, ma'am.
Right. Yeah, I hope that after Kushagra's clarification, now it is clear. If you want me to go over it again, then please post. I just will go over it again. Is there other way of asking how many triangles are possible from given array of numbers? Yeah, it is. That is right. Okay, repeat. I'll repeat. Clear. Okay. So, what we are here. So we already have all of these. So I'll repeat the overall idea. Okay. So we are choosing one number and we are starting from the right hand side. So we are fixing one pointer to the right hand side number, and then we have this left subarray. So in this left subarray we have two pointers, one at the start of the subarray, and the subarray always starts at index 0, and the one at the end of that subarray. Okay. And so now since we have these three pointers, right, we will check whether this forms a nice triplet or not. Okay. So after that we are going to sum these two numbers which are pointed by the left and the right pointer, and if the sum is less than the third number, then we are going to increment the left pointer. Okay. Now why we are incrementing the left pointer is because we want to satisfy the property that the third number is less than the sum of these two. Okay. So we increment the left pointer. Now when this property is satisfied, then all the numbers which are between these two numbers, left and right, with 7, they will satisfy. Again, so all the numbers from left, which is like, for example, here. So I'll just make this. Okay. This is far say this one. So 3 plus 5, yeah, here. So if you will do the run, you will find that 2 plus 5 is equal to 7. So we will increment the pointer to 3. So 3, then 3, 5, 7 will be one nice triplet. 4, 5, 7 will be the other nice triplet. So we will add to our answer 2, which is because there are two numbers here. So basically if you represent this, so let's say there is a left pointer, there is a right pointer, so you will add to your answer right minus left. That is the number of triplets that are possible when you are changing only the left element and keeping the right two elements in the triplet. So this will be like 3, 4, 7 is 1, 4, 5, 7 is 1. After that you see that 3 plus 5 is 8. 8 is greater than 7. So after that you are going to decrement the pointer. So decrementing the pointer, now the pointer will come at 4. So sorry, now when you decrement the pointer, you are going to check and get this new triplet 3, 4 and 7. Then you check whether this is nice or not. This is not nice, right? uh, so then you are going to move, you are going to do this iteration like this, and whenever you are going to see that left and right, like whenever you will increment and it goes like left is greater than right, then you are going to, or right is less than left, then you are going to terminate, I mean you are going to break. Okay, okay, just let's quickly look at the implementation of this, which is very simple, and I'm sure you will just quickly understand, and you can do it yourself also, but I just wanted to show just for the sake of completion. So we first sort the array. We are going to start from the end of the array here. I, one pointer I'm calling I, other two pointers are L and R. R is equal to I minus 1, L is equal to 0. So while L is less than R, then we are going to here find the sum of these two numbers. If the sum is greater than the number which is at ith index, then we are going to add to the answer R minus L, which I have already explained, and I hope it is clear, and this was clarified by Kushagra. And then we are going to, since the sum is greater than V of I, we are going to decrement the R pointer, otherwise we are going to increment the left pointer. Okay, okay, great. So I wanted to discuss two problems. So the second problem is very simple, and I hope we can discuss in just 10 minutes more. So let's do this. So it's simple. The problem statement is like this, which is, so let me just read it. The statement is big, but the problem is just simple. So you have decided to join a local study group for this NPTEL course. You are going to be visiting n-1 fellow learners who happen to be there. These n learners, including you, are numbered 1 through n, and the amicability of learner I is AI. The n learners will arrive at the place one by one in some order. To make sure nobody gets lost, you have set the following rule. Learners who have already arrived there should form a circle, and a learner who has just arrived there should cut into the circle somewhere. When each learner except the first one to arrive at the place, the learner gets good vibes equal to the smaller of the amicability of the clockwise adjacent learner and that of the counterclockwise adjacent learner. The first learner to arrive gets 0 good vibes. What is the maximum total good vibes that the n learners can get by optimally choosing the order of arrivals and the positions in the circle to cut into? So I'll since we do not have much time, I'm going to take an example, and with that example only I'm going to explain the problem. Okay, so let's take here. So we are given, so input is input is again n numbers. Okay, n numbers, like let's say 4, 3, 2, 1. We are given 4 numbers. Okay, and so it is being told whenever, so every number is actually say a person. So every person, there are 4 people, every person has a number which is 4, 3, 2, 1. So whenever a person comes, they always form this circle. Okay, so whenever the first person comes, there is no other person, so it just starts to form the circle. So here first number is 4, so 4 comes here. Then let's say 3 comes, so 3 will come here. Then let's say 2 comes here. Then 1 comes here. So now the question, and then the question says, whenever this person cuts the circle, like initially since there was no circle, so 4 started the circle, then 3 came and cut the circle. That is called a cut, right? So then it will get the number which is on its clockwise or basically there are two edges, right? One on this side and one on this side. So whichever number is the smallest one, that it will get. So like 3 will get 4. I'm just overwriting 4 because there was only one number. 4 got 0. 2, when 2 enters, so 2 enters here. On one side there is 3, on the other side there is 4. So it will get the smaller of them, which is 3, right? And when 1 entered, it can enter now at all these positions. I'm just going to rub this. Okay, so now the fourth number is 1. So 1 can enter at how many positions? 3 positions. If it enters between 2 and 3, it will get 2. If it enters between 2 and 4, it will get 2. It will get the smaller of the two. And if it enters between 3 and 4, it will get 3. So we will enter it here and it will get 3. And our goal is to maximize these numbers which they are getting. That is 3 plus 4 plus 3 plus this is always 0. And the answer here is 10. So that's our goal. Our goal is to maximize the numbers sum of the numbers that they get. Okay, that is called the good vibes in the question. So is the problem statement clear? I'll repeat. So there are n numbers. Okay, we have to add these numbers in a circle. And so whenever we add a number to a circle, and if there are already, let's say there are 2 numbers adjacent to it, so we are going to add it always between 2 numbers. So when we add it between these 2 numbers, it will get the number which is the smallest of the 2. Okay, and every new element is going to get this number, and we have to optimize the sum of those numbers. Okay, sure. Let me post this in the chat box also. This is just very simple. Just bear with me 5 minutes more. So we will do just couple of more examples, and I'm sure you will just get the answer. Okay, so the next example in the problem statement is for numbers 2, 2, 1, 3, right? So again, using our whiteboard here, I don't know how to move this one. Okay, so let's clear this. So our input is 2, 2. What was the input? 2, 2, 1, 3. Okay, so 2, 2, 1, 3. So first number which is going to get into the circle will always get 0 vibes. So if I add 1 in the circle first, is it beneficial to add the smallest number in the circle first or the largest number in the circle first?
Largest.
Right, the largest one. So if I add here, we will add here the largest. And why the largest? The largest because the next number we are going to add will get the vibe equal to this number. So that's why we are going to add the first number as the largest number. So it's like it's a greedy way, right? And then now again, what should be the next number? Should it be the largest from whatever is remaining or smallest?
Largest, obviously.
Right. So again the largest, so 2. So 3 got vibe 0, 2 got vibe, tell me, anyone?
3.
3, right. Then the other two remaining numbers are 2 and 1. Where should I add 2? Or which one should be added and where?
Ma'am, 2 and 1 both should be added on the either sides of these two remaining sides.
Great, great. So 2 can
Because
be,
we can get amicability 2.
yeah, we will get 2 only. We will get the smaller of 2 and 3, and we can add anywhere. So this gets 2, and then we are left with only one number, which is 1. Now where should 1 be added? Again here it does not make any difference, because if I add it between 2 and 2 it gets 2, 2 and 3 also gets 2, and here it's also 2 and 3, so we can add it anywhere and it will be here. So this is again going to get 2. So the answer is this 7. Okay, and so now can anyone tell the solution? I mean, if you have any ideas. Yeah, the recording provided. I'll just keep the statement open for you, and there is one more example.
I'm going to enter the new number between the pair which has the largest term.
Which has the largest number, which has yeah, we are always going to use greedy approach, so right, that is true. So whatever vibe is the optimal right now, we are always going to enter the next number there, and also we are going to always enter the number in the descending order from largest to the smallest. That way we can always optimize. Pretty confused here. One solution I thought failed terribly. Okay. If the problem statement is not clear to anyone, please let me know. Yeah, sorting is pretty much everything. Just do a few examples and you will be able to reach the solution pretty quickly. Okay, I will, for those who did not understand the statement, who did not understand the problem statement and would like to see another example, now I am going to solve another example, and if you have understood the problem already, you can think about the solution to it. And if you have thought of the solution, then feel free to tell me your idea along with the time complexity in the chat box. Okay, so we are going to look at this. So let's assume, so let's say that our input is 7 6 5 3 2 1, which can be in any order, but I have again sorted it here and from the descending order, because we are going to enter these numbers in descending order in the circle, right? So first we will add here 7. So here we are adding 7. Next number is 6. So we are going to add here 6. I'm going to have one more 1 here. Okay. So now 7 will get the vibes. I'm going to write with red so that don't get confused. This will get 7. And next we are going to add 5. So 5 can be added anywhere here. So here we are going to get the vibe, what, 6, the smaller of 6 and 7, right? The smaller number, wherever we are adding this new number will going to get the vibe equal to the smaller of the two adjacent numbers, so which is 6. Next we have 3. Now 3 we can add between 6 and 5, but if we add between 6 and 5, we are only going to get 5. We add between 5 and 7, we will again get only 5. But if we add it between 6 and 7, we are going to get 6. So we are going to then add 3 between 6 and 7. So we'll add it here. And therefore 3 gets vibe equal to 6. Then we have 2. Now 2 we should add here or between 5 and 7, because then only we will get the vibe equal to 5. If we add in these two, like this one or this one, if we add it here in these two positions, then we will get vibe equal to only 3, right? So here we will get vibe 5. Now we have 1 again, we will add it here, 1 here, and then 1 will get vibe equal to 5, right? And then last is 1. So 1, where should we add 1? If we add here between on any side where 2 is there, we'll get only 2. On any side where 1 is there, we'll get only 1. Here we will get 3, here also we'll get 3, so we will add it here, 1 here. So at least 3 we will get. So this is 3. So the answer is 5 plus 5 plus 5 plus 6 plus 5 plus 7 plus 3 plus 6, whatever that answer is. So that is the answer. Okay. Now I'm going to check if there are any approaches. Was confused, there is any other optimization approach, else it seems to be n square here. Why is it n square? How we represent the second numbers?
I thought n square because we are kind of doing for every number and we are checking in the remaining. Okay, one thing I didn't consider is that let's say one number goes into the array in the circle, and so when the next number goes, it will check only for the numbers which have went already. So yeah, it still be kind of n square. I think I'm confused right now. But what I'm thinking is that let's say we have n numbers. So for every number, we have to check in the elements which are in the array to find a perfect position, and it will be sort of a linear search, I guess.
I think you're thinking very complex. It's just very simple actually.
All right.
Yeah, it's okay. I think I just rushed you guys with the second problem. That is why it is happening. I'm sorry for taking too much time on the first one. How we represent the second numbers, ma'am? Okay, you mean the vibe? Okay, the vibe is actually you can keep adding. You can keep a variable answer and you keep adding the vibes to it. So you don't need to store them anywhere. So you just add them like 0 plus 5 plus whenever you are adding this number in the circle, you whatever the vibe you are going to get, you add it to the answer. That's it. We will check the pair for which the minimum between them is the maximum among all pairs. And that again I feel is something a little complicated.
Can you explain what I am understanding right now?
Sure, sure.
Okay, so can you go back to the example that we have?
Okay, this one.
Yes, ma'am.
Sure.
So here, let's say first we have an array which shows the numbers which are already in the circle. Okay. So
Okay.
in the initial step, the array will be empty because we obviously don't have any number.
Right.
Then we first explicitly add the first number into the array because we know it will go and with a value of 0.
Right.
Then for every subsequent number from 6 to 1,
One.
we will add it in the array somewhere where it will get the highest vibe, right?
Right, right, right.
Yeah. So what I'm thinking is we'll check for every possible position,
Right.
and there will be equal as many positions as there are number in the array, right? For every number, let's say currently we have two numbers, so there will be two positions where the number can go, and if there are three numbers, there will be three positions.
Not three. Two only. We can add. Okay, right, right. Yeah, sorry, you are right.
Yes.
Yeah, three.
Yeah. So we have three numbers. It will be three positions.
because
Two
it's
number, two
circle.
positions. So for every number, it will check in every position, like which position would be better, the best, right? A linear search.
Right.
Yeah. So that way, I'm considering it to be n squared.
Yeah, yeah.
Uh,
Sure.
yes, ma'am.
Okay. Yeah, that could be one of the approaches, right? Anybody else wants to share the thoughts? Them is the maximum among all pairs. So Abir, I got you. You are right. So what you're saying is right, actually. Which is similar to Kushag's idea. I mean, you both are saying the same thing. You're going to find the pair. You're going to find the best position, basically. That is right. Right? So it is also very simple. What you're saying are right. So let me tell you the solution that I have, because we are really out of time. So 7 6. So first we sort it, right? So that takes n log n time. So that is done. So whenever we are going to add a number, I'm going to use some. I hope I can use the same example. So first whenever we add a number in the circle, except from the first number. So first number is this. So whenever we add this, we have created nothing. There was nothing. But whenever we add a new number after the first number, 6, we are actually creating two edges, and these two edges have this as the minimum, right? Because we are adding in descending order. So these two edges, which is when we I will clear. No, I don't want to clear this, but I just want to keep it, and also let me make a smaller one here somewhere. Okay. This is, I'm saying 7. This is, I'm adding 6. So now there are two edges, I'm saying, or two positions where the minimum is 6. It is true here. There are two positions where the minimum is 6, right? So next two numbers, I'm only going to add to these two positions. right? Is this clear? Okay. So next two numbers I'm going to add to these numbers. So next is 5. I'll add here 5 without even thinking, let's say. And then, so these two numbers also which I am adding are going to create two edges, with them being the smallest number. I mean the vibe of those two edges. So here for 5 it is this edge and this edge, and for 3 it is this edge and this edge, right? So when you added 6, you got two optimal places where the vibe is 6. So next two numbers you are going to add only on these two edges, right? Now next two numbers which are 2 and 1, where will you add them? You have used 6. Now 6 positions are not left, but 5 positions are left. Now you are left with 2 positions which were created by 5. So you are going to use 5 positions for 2 and 1. This one and this one. So now when you add here, you will add here 2. You will add here 1. Next number when you get, you have exhausted 5 also. Where will you add? You will add it wherever you have the 3. 3 also created 2 edges. So next two numbers, if there were more numbers, let's say 1 was also there, you would have added 1 here and 1 here. So then you would have exhausted this. So basically what I'm saying is that 6 will get vibe 7, 5 and 3 will get vibe 6 and 6. 2 and 1 are going to get, I'll just clear, I don't want to clear, like, let me 6 right here. 7, 6, 5, 3, 2, 1, 1. This is our original array. I'm saying 7 got vibe 0, but 6 will get vibe 7, but next two numbers are going to get vibe 6 and 6. 6 and 6. Next two numbers are going to get vibe 5 and 5. Sorry, I'm not able to write properly. And next number is going to get vibe 3. Now, isn't this simple? I mean, do you need...
Yes, ma'am, got it. Yeah. It will be O of n then.
Yeah, O of n, and you do not need to maintain that other array where you are going to...
Yes, ma'am.
See which is the most optimal order, because it is only that the first number is going to get the vibe equal to the largest number. All the other numbers you just assign them equal to from the largest to smallest, 2 times. 6 6, you just repeat every numbers 2 times. Basically you are going to take this array and repeat these numbers, the first number once and all these other numbers 2 times until you exhaust the numbers, and then take a sum of them. I mean, you don't need to create this array, I'm just saying. I hope...
Ma'am, totally clear it is.
Okay. I hope it was clear to others also. Please, if it is not clear, you can look at the recording, and I'm also going to show the code very quickly. So here answer is this is just sorting. So sorting, I have used one comparator here to do descending order sorting, that's all. And answer is initially 0, and number of vibes that we can pick, basically the non-zero number of vibes will be n-1, because the first number, which is the largest number, does not get any vibes. So whenever the number of vibes becomes 0, then we are going to... So if the number of vibes is not equal to 0. Basically I'm checking that there are non-zero, because n can be 1 also. In that case the answer will be 0. And then we were going to add the largest number to the answer. After that we'll decrement the number of wipes. Now until when the number of wipes is not equal to 0, we are going to check if number of wipes is greater than 1, that is number of wipe it is at least 2, then we are going to add the largest number to this. Then we are going to decrement the wipes by 2 if only one element is left, like only number of wipes is 1, then we are going to add v of I to the answer, and we are always going to increment I plus plus. I hope it is not, I'm not sure, I don't think, it may not be clear, but the solution and the recording will be available, so you can look at that after the session also. So if anybody did not understand anything and want me to repeat, they can stay back. Others who have understood and does not want to continue can leave. I will not be discussing anything new now in today's meeting. Okay. Yeah, thank you for the interactive session. Thank you everybody for answering the questions, and it was really nice. Since there are no questions, so we can end the session here. And if you have any questions related to the session, please post in the Discord channel. Try to post in the week 2 channel. Okay, thanks for joining. Yeah, I have posted the link to the week 1 recording in the Discord channel, week 1 Discord channel, and even Neptal announcement was made few days ago that the recording is available, so they have also provided the link. You can check. Yeah, I can share the Discord channel link.